Okay, in lesson 2, we're actually going to solve some right angled triangles, which is something you did a lot of in grade 10, so you should be pretty familiar with it. To do that, first we're going to set up our primary trig ratios by seeing what we have here. So here's our angle here. Now, depending on the way you like to set this up, will be a little bit different. Let's first identify the hypotenuse. That's the easiest side. So the hypotenuse is across from the 90-degree angle. So there's the hypotenuse, or if you prefer to use r. Now the adjacent side is the side that's next to our angle. So since our angle's kind of flipped around here, our triangle's flipped around, this would be the adjacent side, or the x. And the side across from it, the opposite side, is over here, or the y. Now, for those of you that like to use r sine theta and r cos theta, you're probably already comfortable using that method. So what I'm going to use is the most popular method, which is SOHCAHTOA. So in this case, let's identify what we have. We have the adjacent, and we have the hypotenuse. So we think about SOHCAHTOA. Which one are we going to use? We're going to use CA, because we have the adjacent, and we have the hypotenuse. So that means we're going to use cos. All right, so let's set that up. Using what we learned in our last lesson, cos of an angle is adjacent over hypotenuse. All right, and like we said, we have the adjacent and we have the hypotenuse. So let's sub in. So cos of theta equals 12 divided by 13. All right, so we can use that to solve for the unknown angle. Now to do that, we're going to have to take the inverse of cos. So we take the inverse of this side, it cancels out cos. We have to take the inverse of the other side. Now, how are we going to do that? Well, we got to get our calculator out, and first thing was we want to make sure we're in degrees, not radians. So my calculator here shows degrees right there, so I'm good. So I'm going to go, what's 12 divided by 13? Now, in your calculator, you might have to do the second cos first and then do that. In this calculator, I have to do the 12 divided by 13 first. Then I'm going to go trig functions here, and I have to go second cos. There we go. And we get 22.6. So let's just round everything to approximately 1 decimal place. All right, so theta is equal to approximately 22.6 degrees. There's my angle. All right, let's just try some more. I'm going to walk us through a bunch, hopefully reminding you. There's also some good examples in the textbook you can read. So let's check out the next one. All right, so first I'm just going to label my sides. The side across from C here is the hypotenuse, or if you'd like to use r. The side next to the angle that we're talking about, wherever that angle is, that's the adjacent side, the side that actually touches it. And finally, I'm going to do the opposite, which is across from the angle there. All right, so what do we have? We have the opposite and we have the hypotenuse. So think about SOHCAHTOA. Which one are we going to use when we have opposite and hypotenuse? We're going to use SO, because when you have the opposite and the hypotenuse, you use sine. So sine of an angle equals opposite divided by hypotenuse. And let's substitute in what we know. Sine of the angle is the opposite is 10. The hypotenuse is 11.9. Do the same thing. We're going to go 10 divided by 11.9, and then we're going to take the sine inverse of that. Now when you do your homework, you're not going to have a lot to do, so I need you to write out the steps and show all these steps. Show the initial setup, what you're going to use. And again, if you instead don't like to use opposite over hypotenuse, if you prefer to use r cos theta, r sine theta, you can do that too. Then substitute in your numbers, show the inverse, and then the rest you can just go to your calculator and do it, and that's exactly what we'll do right here. So most calculators, you actually hit second sine first to get the sine inverse, and then you punch your numbers in. On this one, I have to do it in the opposite order. So I have to go 10 divided by 11.9. Okay, and I got that, and now I have to go to my trig, hit second sine, and I get 57.17, so we're going to say about 57.2. All right, so let me just go back there. There we go. 57.2 degrees approximately. There's the angle. Done. All right, let's do some more. Okay, so here's the next two. So far we've seen a sine example and a cos example, so we're probably due for a tan example. Let's start by identifying the sides. This is the hypotenuse. How do I know it's the hypotenuse? It's the longest side of the triangle, of the right angle triangle, and it's across from the 90-degree angle. The next side I'm going to identify is the side next to my angle, which we call the adjacent, or x. And the side across from that we also call the opposite. Okay, so in this case, what do we have, right? We have adjacent and we have opposite. So we go to SOHCAHTOA and we say, well, which one do we use? We're going to use TOA, because we have opposite and adjacent, and that means we're going to use tan. All right, so I'm going to write out tan of the angle equals opposite over adjacent. So you guys really want to get yourself familiar with these. I know at home you can kind of just keep looking everything up, but as we move in the future, if we come back to school, you know, we have this stuff on exam, etc. And next year you got to really know these. So opposite, 4 over 13, that's what tan theta is. The opposite side from the angle divided by the adjacent, and then we're just going to do tan inverse. So pretty easy stuff. This all should be review from grade 10, but stuff you really got to know. All right, let's bring up our calculator again. Let me just clear this out. All right, so I'm going to go 4 divided by 13. Your calculator, you probably hit tan inverse first, and I'm going to do tan inverse second here. All right, we got 17.1 approximately. Boom, done. That's it. 17.1 degrees approximately. Don't forget the degree symbol. I might have forgotten the earlier questions. All right, I know it's getting pretty boring, but I'm going to do a few more quick examples here. Ones where we have the angle and we're looking for a missing side. Okay, so those first three are an example of you have the sides, but you don't have the angle. Now we're going to do the opposite here. All right, so for the one next to it here, let's start by just identifying everything again. This is my hypotenuse. Okay, the side next to the angle we call the adjacent, and the opposite side we call the opposite. All right, so you want to identify those first. Now, here's the thing. We have an angle, we have the adjacent, and we're looking for the hypotenuse. So we need to use either SO, CA, or TOA, sine, cos, or tan. Which one involves the adjacent and the hypotenuse? So again, when you're doing this, just write it down the top of your page, right? SO, CA, TOA. All right, so I'm looking for the one that uses adjacent and hypotenuse. Adjacent, hypotenuse, that would be cos. All right, so here we go. Cos of an angle equals adjacent over hypotenuse. Okay, so set it up this way, or if you prefer to just use x, y, and r, it's the same thing. All right, so let's substitute in what we know. We know cos, we know the angle is going to be 37 degrees. We know the adjacent is 11. We don't know what the hypotenuse is. So I'm just going to, instead of writing hypotenuse, I'm just going to use x because that's what they used here in the diagram. So instead of writing the word hypotenuse, I'll put an x there. All right, so now let's multiply both sides by x, which moves the x to the top over here. And then we're going to divide both sides by cos of 37. And you could have done that all in one step instead of two like I'm doing. All right, now it's calculator time. Let's see how well I do on this calculation here. All right, so we're going to go, what's 11 divided by, oops, this could be a little tricky here. Where's my clear button? There we go. 11 divided by, oh boy, I'm going to pause this and redo this. Okay, here we go. What is 11 divided by cos of 37? Now, in your calculator, you probably hit cos and then 37. This one, I actually have to hit 37 and then cos. And then hit equals, and we get 13.77. So we're going to say the length of that side x, which is the hypotenuse of that triangle, is approximately 13.8 units. Now, I don't know if it's centimeters, meters, doesn't say. But remember, it's a length. It's not a degree. We're not solving for the angle this time. We're solving for the missing side. All right, let's check out 3 more. And that's the end of this video. Okay, let's check out another one here. We have this angle. There's our angle there. So let's identify all our sides first. Okay, so the side across from 90 degrees is the hypotenuse. The side next to the angle is called the adjacent, and the opposite side across from it is called the opposite. Okay, so we're solving for x. We're solving for this here. So we need one of the trig functions that includes the adjacent, and we also have the hypotenuse. Okay, and we have that angle there, the adjacent angle. So what are we looking for? Is it sine, which is so? No. Is it ca? Yep, because we're looking for the adjacent. We have the hypotenuse, so we're going to use cos. All right, so let's set up again. Cos of an angle equals adjacent over hypotenuse. Okay, so let's sub in what we know. We know the angle this time is 60 degrees, and we know the adjacent is x, and we just don't, we don't know the adjacent, which is x, and we know the hypotenuse, which is 11, so we're going to multiply both sides by 11. 11 cos of 60 degrees equals x. All right, so I'm just going to flip it around, go to my calculator, and let's do it. Clear everything out from before. All right, I'm going to do the 60 degrees cos first. So 60 and cos of 60 is 0.5. Times that by 11 and 5.5. And that's the length, 5.5 units. 5.5 units in length. Could be centimeters, meters, whatever it is. Okay, so this next one here, let's just do the same thing. Let's identify all our sides. Okay, so that's our hypotenuse. The side closest to the angle touching it is the adjacent, and the side across from it is the opposite again. All right, so let's identify what we have. We have the hypotenuse, we're looking for the opposite. So we need the trig function that does that. So let's check it out. I think that's going to be sine, because so opposite, definitely looking for it. Hypotenuse, we have it, so we're going to use sine. All right, so sine of an angle equals opposite over hypotenuse. Let's substitute in what we know. Sine of 37 degrees equals the opposite is x, and the hypotenuse is 10.3. All right, so let's multiply both sides by 10.3. 10.3 times sine of 37 degrees equals x, and we'll just punch that in our calculator and see what we get. 37. Take the sine of that, not sine inverse, sine, right? And then times it by 10.3, and it looks like we get about 6.2 when we round it. All right, so x is 6.2. Now don't mix these x's up with the x's from my original diagram from the previous lesson, the x side, the y side. And all these cases, they're just using x in these diagrams to mean the unknown. We could use anything. So that's why it gets a little confusing with the x, y, and r, which is why I'm sticking with opposite, adjacent, hypotenuse, those instead. So we don't kind of mix all that stuff up. All right, one final hang on. Okay, in this final example, I'm going to move some things around based on versus what's on our handout and our sheet here. So I'm going to change this up. All right, so what I want to do is I'm going to make this side the x, and actually let's leave this side as 9 over here. So we're just going to switch where the x is. The x was there, now it's up here. Okay, so let's label our sides. Hypotenuse is over here. We don't know the hypotenuse. The adjacent is the side next to the angle, and the opposite is the side across from the angle. All right, so we just got to figure out which trig function to use. So again, we're going to check out SOHCAHTOA. SOHCAHTOA. This is basically, again, a mnemonic device to memorize. You know, students write at the top of their test pages so they remember what to use. So if we're doing sine, we need opposite and hypotenuse. We don't have the hypotenuse. We do have the opposite, but we're not going to use sine. If we're going to use cos, we need the adjacent and the hypotenuse. Well, we're looking for the adjacent, but we don't have the hypotenuse, so we're not going to use that. Tan, do you have the opposite? Yes, and we're looking for the adjacent. So we need the trig function that involves both of those, right? Because we have the adjacent over here and the opposite over here. So we are going to use tan. All right, so tan of an angle is opposite over adjacent. So let's sub in what we know. Tan of 51 degrees is 9 divided by x. All right, so we're going to multiply both sides by x, which moves the x to the top on the other side, divide both sides by tan of 51, which just moves it to the bottom of the other side, and let's punch this all in our calculator. So I'll bring up my calculator here. Let's clear it out. All right, so I'm going to go 9 divided by, now this is where it gets funky on my calculator. I have to hit 51 first and do tan first, and then hit equals. All right, whereas you will do tan of 51. And it looks like we got about 7.3, 7.288, so we're going to say that's 7.3 approximately units, and that's the length of that side. All right, so your homework for this section is to basically do the same thing. When you do it, make sure you show me what you're setting up. Okay, label on your triangle what side's going to be what, like I did over here. Show, you know, your setup step, show how you isolated, and then write your final answer. Okay, so do a neat job. It's not super difficult work. It's just review from grade 10, but I want you to show some steps, not just a final answer if you want to get credit.